By investigating the concavity of the curve y equals x to the power 4, explain why the curve does not have a point of inflection. A sketch of the curve may be useful. Okay, so the moment we talk about concavity, we're looking at the second derivative. So I'm going to say if y equals x to the power 4, first derivative equals 4x cubed, the second derivative equals 12x squared. Now, point of inflection is where the second derivative equals 0. So that is where 12x squared equals 0. Divide by 12 is both sides, so x squared equals 0, therefore x equals 0. Okay, so point of inflection is where x equals 0. Now I'm going to do my table, my gradient table of the second derivative. I'm going to have x, I'm going to have the second derivative of y. I have three values, 0, less than 0, more than 0. So let's go -1, +1. If I put -1 into my equation, into my second derivative, -1 squared is +1 times 12. That is positive. That is 0. And this is, if I put 1 in there, 1 squared is 1. 1 times 12 is 12, so it's also positive. Because the signs does not change, it means that this is not a point of inflection. Right, so the second derivative does not change the signs either side, therefore x is not a point of inflection. Okay, because both sides are positive, we know that it's concaved up. So you can write all of that in words. It's going to take me ages with this pen, and you won't be able to read it. But this is what you need to understand. Because this is, if this positive and this positive, because they don't have different signs, we do not have a point of inflection. But because both of them are positive, on the left and the right, it means that it's concaved up, because if it's positive, I am smiling, so it's concaved upwards. If you then draw the sketch of, if I draw y equals 12x squared, or y equals x to the power 4, I know that x to the power 4 looks like this. And therefore there's no point of inflection. There's just a 0 point over here.